Hey y'all, this is the Unit 7 review video. Again, this is going to be a quick, down and dirty, trying to talk through this entire unit in 20-25 minutes. The review is up on Google Classroom, and again, you can work these problems. The answer key is up there too as extra practice, but this is walking you through all of the concepts from Unit 7. So the first thing to look at are these general understanding questions. Basically, if you can answer these questions, you'll probably be okay for the test. So how many answers should you typically find for inverse values? I'm going to give you a hint. It's 2. Please don't forget to find your second quadrant when you're looking at most of these problems. What is the difference between finding an inverse value between 0 and 2 pi, finding a general solution, and finding a principal inverse value? Remember, it's what your answers look like. So if you're finding a value between 0 and 2 pi, you should have an angle measure in radians, and these should typically have 2 answers. Okay, again, there's going to be 2 answers if you're just looking between 0 and 2 pi. They should be positive answers, and they're in radians. If you're finding a general solution, you're still going to have 2 answers. However, those answers can be negative, and they should all look like little sentences that say plus 2 pi n at the end of them, because you're telling me where are all of the solutions for this particular equation. A principal inverse value, if you're looking for a principal value, there is one value and it falls in the restricted range for that inverse function. So again, you're going to solve all of these the same way. Really what it boils down to is how many solutions do I have and what do those solutions look like? When solving a trig composition, number 3, how do you think, or how do you know what kind of answer, angular ratio, your final answer should be? That's definitely looking at, do you have an inverse or an arc on the inside or the outside of all of your parentheses? So remember, if you have an inverse on the outside, you're going to be looking for an angle answer. If you have an inverse on the inside, you're going to have a ratio or a numerical answer. Still going to put some triangles on there, depends on how many triangles you're going to need. However, you're always going to get that certain type of answer depending on where the inverse is. Remember that this is not a calculator unit. This isn't one where I've told you plug this into your calculator, figure out what the answer is. Your answer should be exact. They shouldn't be decimal approximations. Wow. They should say like pi over 6, 2 pi over 3. I don't want to see decimals. I don't care about those decimals. You should be able to clearly explain your work. If you're someone who you use the unit circle to find these values, great. How did you find that particular value? Tell me your steps. Okay, if you're someone you draw triangles, great. Draw me your triangles. Show me how you did it. Okay, half of your calculus test next year will have no calculator on it, and I promise a lot of it will be the evaluating stuff. So this little, what is this? A flow chart. There you go. It will help you go through and kind of walk through how am I supposed to solve this problem? The first question it asks you is how many inverse trig functions are there in the problem? Remember, that's an arc or a -1 on there. If there are no inverse values, it's an exact value. This is from Unit 5. Oops, it says Unit 6. My bad. It's from Unit 5. Okay, that's just drawing your triangle, finding the ratio answer. If you have one arc or inverse notation in your problem, this is the set of steps you're going to use. And then you're going to ask, what are they asking for? Do you want the 0 to 2 pi? Again, that's going to have 2 answers. Do you want the general solution? Again, that's going to put a plus 2 pi in. Or do you want the principal value? That's the one answer that's in the restricted range. If you have one inverse, but there's 2 functions total, so you have an inverse sign, but a normal cosine, then you think about your composition rules. You think, is the inverse on the inside or the outside? Follow these steps, make sure you have a ratio answer. If the inverse is on the outside, follow these steps, you'll get an angle answer. Again, this little flowchart should be in your review. If you wanted to look at it, it's the last page. So there you go, just a little quick walk through that. So let's start with 7.1. So 7.1 were the inverses between 0 and 2 pi. So again, this was the time when 95% of the time you should be getting 2 answers. There are very few cases where you won't get 2 answers, and most of the time that deals with those ones and -1s. So the first step that you should do is think about what quadrants your triangle should be in. So when you look at this particular problem, again, you see that there's a negative inside the parentheses. So there are a couple of ways to think about this. Again, sine on the unit circle goes with y, so I want to know where y is going to be negative. Or you can use this handy dandy mnemonic, the all students take calculus, that tells you where each of the trig functions are positive. So this is going to tell me where things are positive. So all are positive in 1, sine is positive in 2, tangent's positive in 3, and cosine is positive in 4. Remember that the reciprocal values will follow the same sign rules, so the SIGN, if it's positive or negative, as its reciprocal. So sine and cosecant would go together. So anywhere sine is positive, so is cosecant. Since this one is a negative value, I'm going to go through and see where sine is positive and rule out those quadrants. So since this one's negative, I can't be in 1. Everything's positive in 1. And sine is positive in 2, which means my 2 angles need to be in quadrants 3 and 4. So I'm going to go through, now I'm going to draw and label my triangle with what was given to me in the problem. So, wow, that was a work of art. Okay. This is my triangle in quadrant 3. Again, your angle is always going to be the one with the x-axis, always with the x-axis. So when I label this, I know that sine, so katoa, is opposite over hypotenuse. So my opposite leg is -1, and my hypotenuse should be 2. My hypotenuse is never the negative value. Your leg will be the negative value. Your hypotenuse should be positive. Now that I have this, I can go and either use my Pythagorean theorem to find my last leg, or realize that with my reference angles only being 30, 45, or 60, this should be one of those special right triangles. In fact, it is. This is a 30, 60, 90, so this last leg should be √3. It is negative. It's not really going to affect our problem, but I just want to make sure for posterity's sake, I've labeled it correctly. Okay, so again, this is a 30, 60, 90 right triangle, and the angle that's opposite the smallest side is the smallest angle. So here is my 30-degree angle is my reference angle. So again, my reference angle for this particular problem is 30 degrees, and I'm going to convert that to radians. 30 degrees is equivalent to pi over 6. Again, think about 180 divided by 30. It goes in 6 times, so that's my reference angle. Now, the last thing I have to do is make sure that this is in the correct quadrant. Because if I was to say the answer is pi over 6, that means my answer is in quadrant 1. We already ruled that one out. So I'm going to go ahead and make sure that I get this thing in the right quadrant. For this angle, remember, on my unit circle, this guy's 0 on the positive x-axis, and the negative x-axis is pi. All of your things on your unit circle, all the reference angles on your unit circle are going to be one reference angle away from those x-axis markers. So if I was to rewrite pi as something over 6, it'd be 6 pi over 6. That gets me 1. So I know that this guy is 1 away from 6 pi over 6, or it's 7 pi over 6. Okay, that's my first angle. My second angle, again, we said was in quadrant 4. Everything's going to be exactly the same about this guy. It's still going to be a 30-degree reference angle. All the legs are going to be the same, except for now I need to place this one in the correct quadrant. So over here, this whole half circle was 6 pi over 6. So if I go another 6 pi over 6, this angle could also be 12 pi over 6. So if I'm 1 pi over 6 away from that, that would put me at 11 pi over 6. So my 2 answers would be 7 pi over 6 and 11 pi over 6. And again, this is, once you start seeing these numbers again and again, maybe you'll start to recognize them, but your angles for these answers don't ever simplify. So if you get something like 9 pi over 6, that would simplify down. That wouldn't be an angle on my unit circle. So just be careful of that. Again, there are more practice problems on the review right here. And then again, it does walk you through if you can't draw a triangle. If, for instance, you had a 1 in here where you had a -1 over 1, that's not a real triangle, then you would need to go and use your OIO chart. Because this one is a cosine, I go inverse on the inside. So I go to the cosine column, go to the inverse, that's pi. Okay. Again, be careful. You can draw triangles for some 1s. Tangents and cotangents can be 1. And you see it's not on the OIO chart because, surprise, it's that 45, 45. Okay. But again, make sure you're finding both answers as you're working through these problems. 7.2, general solutions. Notice it has the same steps as finding the inverse between 0 and 2 pi. Now all you have to do is write plus 2 pi n. So I literally copy pasted these steps from the other page. It's the same thing. All I'm going to have to do is add something to my answer. So if I look at this problem, the only problem I see right now is before, if I just scroll back, it already had my inverse. This one does not have an inverse. I need to get x out of the inside of that cosine. And the way I'm going to do that is by taking the inverse of both sides. You cannot just divide by cosine on both sides. Dividing by cosine would be like saying subtract. Subtract what? I don't know. It would be like saying divide by the square root. Square root of what? Okay, again, the inverse operation of a trig function is just the arc, whatever, the arc trig function or the cosine -1 of that function. So I'm going to go ahead and I'm just going to take the inverse of both sides. Whatever I do to one side of the equation, I have to do to the other side. So I end up with something like this. And again, that inverse cosine cancels out this cosine. So I get x equals inverse cosine of -√3/2. Okay, so that was my first step. I guess it wasn't listed in the steps, but now I can do the same steps that I did before. Again, I'm going to look and see that this is a cosine and this is a negative cosine. So if I use the All Students Take Calculus chart, again, if we're looking where cosine's negative, so it can't be in the first quadrant. Everything's positive there. It's not going to be in the fourth quadrant because, surprise, cosine is positive there. So my two quadrants are going to be in quadrants 2 and 3. So I'm going to go ahead and draw my triangle just like I did before. Beautiful. That was much better than my other one. Again, my reference angle is always the one with the x-axis. So I'm going to have that cosine is ka, SOHCAHTOA. My adjacent is going to be my -√3. My hypotenuse is 2. This is, again, going to be one of those lovely 30, 60, 90s because of this √3. Again, you can use the Pythagorean theorem to find the last leg if you need to, but this last leg should be 1. And again, opposite from that 1 should be your smallest angle, so 30 degrees. Okay, so again, I have the same reference angle. You're going to see that reference angle happen a lot. 30 degrees is equivalent to pi/6. So I know now I can place this in the correct quadrant and get my answer out of this. So again, if this one's 0, if this one's pi, I can rename this 6 pi/6. So, oops, I wrote 6 pi/pi, my bad. That's a 6. Here, I'm going to erase that because it's going to bother me a little bit. Okay, so 6 pi/6, and this guy's going to be 1 away going up. So I'm going to have 5 pi/6 as my first solution. But again, I want the general solution, so I'm just going to write plus 2 pi n. Okay, now I'm going to throw it in my second quadrant. Again, in the second, my third, I guess it's in the third quadrant. The other quadrant that it's negative. It's going to be the same reference angle. It's just now I'm going all the way to this piece. So again, it'll be 1 away. But now it's going to be 7 pi/6 plus 2 pi n. Okay, now that you have your general solutions, again, this tells you every single thing that x could be. You can have 5 pi/6, 7 pi/6, and any coterminal angle to those points. That's what the 2 pi n is denoting. So if you need to find another one that would be in the solution, you can either add or subtract 2 pi from each of these angles until you find the next solution. Again, this is just coterminal. That's all that the general solutions are saying. So again, we have some other solutions down here. Remember that when you have a tangent, tangents lie 180 degrees apart from one another, so they're on the same little line. So you don't have to write 2 solutions for that one. You can be sneaky, find one angle, and just write plus 180, so plus pi n. Okay, that it works either way. Both of these solutions are correct. You can either write both of them out or just the one. And then there are, of course, some more examples for you in here if you need more help. Oh, look, that was the one I just did. Moving on. 7.3 and 7.4 are your principal inverse values. When 7.3, we talked about what the graphs of the inverse functions look like. You only need to know the restricted ranges for the inverse graphs, not the pictures themselves. The pictures themselves are a little bit convoluted, crazy stuff. Like, we just need to know, where do these inverses lie? Where did we have to cut the graph off in order to make it a function? So this is my little grouping of where these guys are. So sine, cosecant, and tangent all are going to fall between negative pi over 2 to pi over 2. So basically, they're going to be in quadrant 1 and quadrant 4. So they're that little chunk. Remember, we're not going to deal with quadrant 3 when we're dealing with the principal inverse value. For these guys, cosine, secant, and cotangent, they're going to fall in quadrant 1 and quadrant 2. So they go from 0 to pi. Again, we're ignoring quadrant 3. This is so we can get all the negative and positive values in those sections. Remember, sine and cosine actually can equal to these values. They would have square brackets, whereas the other guys sometimes they have the asymptotes going on. So these are just the values that they're going to fall between. Not all of the values may be defined in that particular range. So remember, for these questions, if you have a principal value, you only get one answer for everything. You're going to make sure that it's in the restricted range of the function, which means it's never going to be quadrant 3. So you can follow the same steps that you did for the other one. Just make sure you don't pick the other guy in quadrant 3. Okay. Remember that if you're using sine, cosecant, or tangent for the one that's between negative pi over 2 and pi over 2, you can just find the reference angle and make it negative. You don't have to worry about thinking, oh, is this 11 pi over 6? What is it? You can just say negative pi over 6. So if I have this example, if I want to find the principal inverse for this guy, tangent of x equals negative 1, again, I would need to take the inverse tan of both sides. I'm just going to do it on top. There we go. So I would have x equals inverse tan of negative 1. So same thing, I'm thinking about where is tangent going to fall? Well, if I had a negative tangent, normally, if I'm thinking about the all students take calculus, that would be over here and over here, right? But I'm going to ignore that part of the graph for this particular value because I have to stay in these two quadrants, in quadrant 1 and quadrant 4. So I'm going to draw my angle in the correct quadrant. Again, there's only one answer to this, so only one triangle. And so I'm going to label what I know. I know that tangent is opposite over adjacent. So my opposite leg should be negative 1. My adjacent leg, if it's not a fraction, make it a fraction, put it over 1. So my adjacent leg is 1. I only know one triangle that has legs that are the same. So this one must be a 45, 45, 90, which would make the hypotenuse root 2. And then I think if my reference angle is 45, what's that in radians? Well, 180 divided by 45 is pi over 4. And because this is down there in quadrant 4 and it needs to fit in this restricted range, I'm just going to make it negative. And done. Again, a principal inverse value, exact principal inverse value has one answer. I don't care about the other quadrant that this would fall into. I just want the one that's in the correct quadrant with the correct sign in front of it, the SIG, and if it's positive or negative. So again, here are some more examples. Notice that the negative cosine is still allowed to be in quadrant 2, so that one you still would need to figure out the 3 pi over 4. And then you see here, if you can't draw a triangle, again, you have to use the OIO chart, but be careful. 3 pi over 2 is not in the restricted range for sine, so you're going to have to make that into a coterminal angle or negative pi over 2. Okay, here are your restricted ranges for your basic functions. Again, sine and cosine are allowed to have the square brackets because they are actually equal to those values, whereas tangent has asymptotes happening on those edge points. So we have to put the parentheses to denote that it can't equal. It approaches, it gets really close, but it can't equal. Next, we have trig compositions. Compositions are going to require you to use the principal inverse values. There's one answer for all of these things. So if you see all these parentheses, that means one answer. If you have an inverse on the inside, remember, inverse on the inside is going to get you a ratio answer. Your answer is going to be a fraction. You only need to draw one triangle. Whereas if you have an inverse on the outside, you're going to actually have to find the exact value of the inside and draw a new triangle using the restricted range. So this one requires one triangle, this one requires two, okay, or pictures, however many. So for this first one, if you have an inverse on the inside, the first thing you're going to do is, of course, draw the triangle. You do need to think about your restricted range. So since this one is a cosine and it's positive, it's not going to change this answer too much, but I can draw it in quadrant 1. And again, cosine is your adjacent over your hypotenuse. So my adjacent leg would be 2. My hypotenuse is 3. I'm now going to use the Pythagorean theorem to find the length of the other leg. So I would have 2 squared plus IDK squared equals 3 squared. And so that's 4 plus x squared equals 9. So then that's x squared equals 5. So this guy would be the square root of 5. You may need to rationalize denominators. If you do, you got this. Okay, just to recognize it. So now, at this point, we've now figured out the angle. You don't need to know what the angle value is because now I want to find the sine. Now I just want to know what is the sine of this particular picture. So the sine of theta here, once I have found this using my picture, I'm just going to go use it and say, okay, well, sine is supposed to be my opposite over my hypotenuse. I know my opposite leg now. It's 5. Sorry, square root of 5 over 3. That's my final answer. Okay, again, this should have given you an angle answer, but I didn't even need to know what the angle was in order to find the sine because I have the triangle. We love triangles. Now, the other one, if you have an inverse on the outside when you're looking to find an angle, the first thing you're going to do is, again, look at this inside piece. Ignore the inverse sign for a second. Find the cosine of 5 pi over 6. This is what we did in Unit 5. So the first thing I'm going to do is draw the angle. 5 pi over 6 is in quadrant 2. How did I know that? Because this one's 6 pi over 6. Pi over 6 is a 30-degree reference angle. Again, pi over 6 is 30. So now I'm going to use that 30, 60, 90 knowledge and label my triangle. I know opposite my smallest angle should be my smallest side. My hypotenuse is 2, and then my other leg is root 3. Be careful, it's a negative over here. Okay, now I'm going to find the cosine of this angle. So cosine is adjacent over hypotenuse. So for this value, the cosine of 5 pi over 6, the adjacent leg is negative root 3. Hypotenuse is 2. So now I've done that piece. Now I'm going to tack on the outside. So I'm going to find the inverse sine of negative root 3 over 2. Again, this is going to involve my principal values. So I'm going to need to draw a triangle in the correct quadrant using my restricted range. So in this case, where's sine negative? It's going to be in quadrant 4 because of the principal values. And now I'm going to label what I know. Again, this is my opposite over my hypotenuse. So my opposite leg would be negative root 3. My hypotenuse is 2. This is a 30, 60, 90 right triangle. Surprise, it's going to keep being that 30, 60, 90. And this one, again, opposite from your root 3 should be your 60 degree. So the angle for that guy is going to be, the reference angle is 60 degrees. So the reference angle would then be pi over 3. And because, remember, this is a principal inverse value, I can find the reference angle, make it negative. That's my answer. So my final answer for this one is negative pi over 3. That answer is, in fact, an angle because it's got a pi in it. So again, there's lots of more practice problems in here if you need to do them. And there's a lot of good ones also on the My Math Lab assignments. So last but not least, we did the variable compositions. The big thing about these is please don't make these more complicated than necessary. This is actually a little bit more straightforward than some of the other ones we did. Don't oversimplify your answer. Just because there's an x in the numerator and an x in the denominator doesn't mean you should be canceling things because sometimes there's a square root around that x. Leave it alone, okay? This is the one time that you don't even have to think about restricted ranges or that there could be multiple answers. There is one answer for this. Your answer will have an x in it, okay? So if I look at this picture or this problem, it says cosine of the inverse cosecant of x. So the first thing I'm going to do is, again, deal with this inside and figure out what the quote-unquote angle is to draw the picture with. So I'm going to draw me a triangle. Well, that was an interesting triangle. I know that cosecant goes with sine. It is the reciprocal. It's the flip-flop of sine. So sine is normally opposite over hypotenuse. So cosecant must be hypotenuse over opposite. So they gave me my hypotenuse is x. Remember, you have to orient yourself. I didn't orient myself. Here's my x, or my theta that I'm looking at. This is the angle. So my variable is going to be x on the hypotenuse. And then again, if it's not a fraction, make it a fraction. It's over 1. So my opposite leg would be 1. At this point, I need to use the Pythagorean theorem to find the other leg. So I don't know what this guy is. I'm not going to use x, though, because, that would get confusing. So I'm going to say that one leg squared plus the other leg squared equals the hypotenuse squared. And then I'm going to solve this for a. That's going to be the length of this other leg. So I'm going to have that a squared is equal to x squared minus 1, because I'm going to subtract the 1. I'm going to take the square root of both sides. Again, don't try to make this more complicated than it needs to be. This expression does not simplify at all. I know there's a square and a 1, but if you factored that, it doesn't factor into a perfect square itself. Leave it alone. Leave it with a square root. Okay? Don't oversimplify. So at this point, I now want to find the cosine of this particular triangle I drew. Again, cosine is adjacent over hypotenuse. I just found my adjacent. Rest in peace to your ears. I just found my adjacent leg. It's that x squared minus 1. My hypotenuse is x. That's my final answer. Do not simplify it any further. There's no pairs that I can take out of the top. The hardest part about these is please be careful of when you square stuff. If you had something like this first problem, notice that you had to take 2x quantity squared. So your answer here has a 4x squared in it. It's not just going to be 2x squared. You have to square every piece of the inside. So be careful if you have an expression that has a coefficient on it. So again, that's Unit 7 in a nutshell. Please use the review and use this fun little flow chart if you need some extra help. Good luck. And again, make sure you've gone through your My Math Lab quiz, and that's a pretty good practice for your test. Have a great day.